Have you ever really stopped to think about how a simple line of code, just digital information, can become a solid, physical object you can actually hold in your hand? I mean, it feels a lot like modern-day magic, right? Well, today we're going to pull back the curtain and break down exactly how that process works. It's a question that honestly sounds like it's straight out of science fiction. You start with this raw chunk of material, you've got a computer, and then poof, a super complex, incredibly precise part just emerges. So how does that actually happen? What's really going on behind the scenes? The magic really boils down to a powerful trio. You need a brain to make all the decisions, a very specific language to give instructions, and of course the physical tools to do the actual work. Today, we're going to dive into each of these pieces to see how they work together so perfectly. So, this amazing bridge between the digital world and the physical one has a name. It's called Computer Numerical Control, or as you've probably heard, CNC. You can think of it as the ultimate translator, turning those digital blueprints on a screen into real-world objects with just incredible accuracy. And really, it all comes down to this simple but revolutionary idea. It's kind of the unsung hero of our modern world. I mean, it's the silent force behind everything from the sleek design of your phone to the critical parts in an airplane. CNC is what makes mass production possible, executing the same perfect set of instructions over and over and over again. All right, so how does this whole translation from digital to physical actually get started? Well, it all begins with the brain of the operation, the CNC controller. And today we're going to be looking at a really cutting-edge example, the Siemens Sinumerik One. The best way to think of the controller is like the machine's central nervous system. It's the command center. It takes that digital plan, the code, and turns it into actual physical action, coordinating every single movement down to a tiny fraction of a millimeter. So what is this brain actually doing? Well, it's a master of three things at once. First, it's reading the program. You can think of that as the recipe. Second, it's acting as the hands, controlling the machine's every single move with incredible speed. And third, it's the eyes, using all sorts of sensors to keep a close watch on the whole process to make sure everything is perfect.
Okay, so we've got our brain, but how do we talk to it? Well, we need a language, and this brings us to the really cool and surprisingly logical world of CNC programming.
Now, at first glance, machine code might look like some kind of secret message, but it's actually pure logic. This code, usually called G-code, is often generated automatically by special software that turns a 3D model into a set of commands. So a simple thought like, hey, move the tool to the left and do it fast, becomes a clean, simple command like G00x-50. It's a language of pure, unmistakable precision. A whole program is really just a carefully crafted recipe made up of these commands. It's like a four-step dance. You position the tool, you start it spinning, you make the cut, and then you send it back home. Each step is a precise instruction, building on the last one to create a perfect final part. And sometimes you've got thousands of these steps happening in just a few minutes. It's amazing. But here's the thing, a CNC machine isn't just a robot blindly following a list of orders. To get that incredible precision, it needs to be smart. It has to understand its canvas, the material it's working with. The controller needs context, not just about the shape, but about the stuff it's actually cutting. And this makes total sense, right? I mean, you wouldn't use the same knife or the same amount of pressure to slice through soft butter as you would to cut a block of hard cheese. The machine has to know if it's dealing with something soft, like aluminum, or a super hard metal like titanium, because the entire strategy has to change based on that. This table here shows that intricate dance between the material and the machine perfectly. With aluminum, you can go fast. It's like a high-speed waltz. But with steel, you gotta slow it down. It's more of a slow, powerful tango to manage all the heat and pressure. The brain uses this information to adjust everything on the fly, changing speeds, altering the cutting path, you name it. Every material has its own rhythm, and the CNC machine is the master choreographer. I love this quote because it just perfectly sums up this whole relationship. The geometry tells you what you're making, but the material tells you how you're going to make it. It's a true partnership, and you absolutely need both to get a successful result. So, we've covered the brain and the language. Now let's get to the fun part, the hands of the operation. These are the actual cutting tools that bring that digital design to life. A modern CNC machine is like a virtuoso with a massive toolbox right at its fingertips. It can hold dozens of highly specialized tools, ready for any job you can think of. It's like a symphony of precision, where the program is the conductor, telling each specific tool when to jump in and play its part. And here's the real kicker. This whole tool-changing process is completely automated. The SINUMERIK One controller is a master multitasker. It swaps out tools with a speed and accuracy that would honestly make a surgeon jealous. It's this seamless ballet of automation, where every single move is calculated and executed flawlessly in seconds. So after all this, the brain, the language, the tools, what's the end result? Well, it's a level of precision that it's just hard to even wrap your head around. It comes down to a number that really says it all. 0.005 millimeters. That is less than 1/10 the width of a human hair. I mean, that's a dimension that's basically invisible. It's an incredible testament to the power of this technology. CNC has totally redefined what we even mean by precision manufacturing. So we've gone on this journey from the invisible world of code all the way to a real, tangible object, all with a level of accuracy that just boggles the mind. It really makes you wonder, right? If our digital dreams can be turned into physical reality this flawlessly, what's next? What new frontiers are we going to unlock?